So this goes with mini review number 3. Because it was all on Delta Math, I figured I would just open up Delta Math problems and show you how to do them. So for the first type of problem, it says we have a function, it's graph below, determine whether the degree of the function is even or odd and whether the function itself is even or odd. So for the first part, where it says determine whether the degree of each function is even or odd, you just have to look at the arrows. In this case, the arrows are going in opposite directions. One's pointing up and the other's pointing down, so it's going to be an odd degree. But that doesn't mean that the function is odd. So in order to have an odd function, you have a rule where you have a point, and for an odd function, you also have the negated numbers of that point. So let's say I'm looking for one that, there's nothing good here. Let's do this point. That's the point about, whoa, sorry, a little shaky, 440. So if this was an odd function, we would have to have the point -4, -40. Let's see, -4. It's not there. So that means this is an odd function, or it's an odd degree, but the function itself is not odd. So we would say it's an odd degree, but the function is not odd. Let's see if I submit it. Is it going to let me? Yep. Let's hope for the green check mark. There we go. Okay. So for the second type of problem, it's a fill in the blank. It says the polynomial f of x is graph below. Fill in the form below regarding the features. So for the first part, the degree. Well, we know the arrows point in opposite directions. So we know the degree is going to be odd. The leading coefficient is, your options are positive or negative. So what you have to do is look at this look at the graph. The arrow's pointing up here, but when you read a graph, you always read from left to right. So see how this one, when x is going to infinity, the y is pointing down. So that means the lead coefficient is negative. And the next section there are blank distinct zeros. So if you remember, zeros are the same thing as x-intercept. So we have 1. That looks like a triple root because it flattens out at the x-intercept. 2, 3. Distinct means different. So there are 3 different zeros. Let's see. It's not going to let me type. I'm writing. I'm not on a keyboard. And blank relative maximum values. Let me erase all this mess. So because the arrows are pointing to negative infinity and positive infinity, there's not necessarily a maximum or a minimum. But relative max, those are turning points. So we have 1 up here, and that's it. So there would be 1. I'm not going to submit this because Delta Math doesn't recognize pen. So now let's go to the next. Select equation from graphs. Which equation could represent the graph shown below? So what you have to do is find your zeros, your x-intercepts. So my x-intercepts on this problem are -7, 1, and 6. Remember, zeros and factors are opposite signs. So that means I have factors of x plus 7, x minus 1, and x minus 6. So now your job is just to look and see which one matches. Plus 7, minus 1, minus 6. I believe it's that one. And that's it. That's all you do for that one. This last one, there's the same idea, except we have a double root. So here we have a 0. It looks like a 0 is about x equals -7. Now, because this graph hits the x-axis and goes back down, this is a double root. So that means we have an x plus 7, and since it's a double, it happens twice, okay? And now we also have a root at x equals -2. So we have another factor of x plus 2. So I could write out my function like this, or because there's two matchers, I could say x plus 7 squared, running out of room, sorry, times x plus 2. So that would be this guy right here. Okay, make sure you let us know if you guys have any questions.